Well, we have numbers like pi, e, square root of 2. Uncreatively, these numbers are called the irrational numbers. And notice how we're drawing this enclosed space specifically away from the rational numbers, because you can't be both at the same time. You're one or the other. Let's look at this a little bit deeper. So we have pi. What happens with irrational numbers is that, as far as their decimals are concerned, they're going on forever and it never repeats. So they have a non-repeating, non-terminating decimal expansion. Well, we would be here forever until the end of time trying to write down all of them, and we'd still never get there. But what we like to do is, instead of saying equals, what you'll do in school is you'll do what's called a rational approximation. And all that means is you put little bacons here and you say that this is really close to 3.14. This is a rational approximation of pi because, well, this is a terminating decimal, therefore this is a rational number. This would be equal to 314 over 100, and then you'd reduce that to lowest terms. Or you just leave it in decimal form like this. And this would be, for what your purposes are, a pretty good approximation of what pi is trying to do. But pi is actually equal to, again, not going to write all of them, but I'll write down as many as I have memorized. Now, I've been asked plenty of different times, how many digits do you have memorized of pi? And when I was in school, other math majors had, over 100 digits memorized, and they'd write it all on the chalkboard, and I'm like, okay, that's kind of cool, but 3.141592653 this is all I have memorized. And really, for anything that I would want to do, this is more than enough, for architects or people trying to use this in the real world. The people who have 100 digits of pi memorized, I got a little bit of sad news for them. So if we were to take pi and expand it out to the 28th digit, and that value is a 3, whatever. If we were to use this rational approximation of pi and use it to calculate the circumference of the observable universe, we'd have a pretty good estimate compared to using the exact value of pi. Now let's go to the next digit, which is the 3 and then a 2. If we were to use this rational approximation of pi to calculate the circumference of the observable universe, we'd have an even better estimate compared to using the exact value of pi. The difference between these two numbers, it's within a meter. We're talking about the observable universe here, something that is billions and billions of light years across. And remember, a light year is the amount of distance that light, the fastest thing in the universe, travels in 1 year. So to go from something that massive, literally the largest thing we can measure, and to be accurate within a meter, wherever that is, I mean, you don't need to be any more precise than that. Numberphile did a similar video. They extended pi out to the 39th digit and did the universe thing. And they compared that to the actual value of pi. It's within the width of a proton. I mean, I've heard of people that have tens of thousands of digits of pi memorized. And, that's cool. I guess that's impressive, but I just would rather use my brain to actually do math. We are going to add a new set. We're not adding any new numbers. We're just kind of enclosing these two sets so they have a home together at last. And these are called the real numbers. As I've drawn it here, you might think that there are real numbers that are neither rational nor irrational. And that's just a limitation to my ability to draw things. We have our pretty picture. Take this picture, put it on your fridge, put it on your wall, get a tattoo of it. Do whatever you need to do to get familiar with these sets of numbers, because we're going to be referencing them a lot over this year, this section, this lifetime of math. And just so you know, there are more sets than just the real numbers. There's a lot more sets, but as far as Algebra 1 is concerned, these are all the ones that you're going to need to be concerned with.